Hi, in this one I wanted to present the std optional class that is in C++17 and how it can help you a lot when dealing with optional values and yeah, how you can rewrite, let's say, previous code to have it. So basically, what you used to do in C or C++ before this would be like the default way to do things is always like if you have an optional value, usually you return like a special value to, for example, if a pointer, if it's bad, you set it to null, which is just 0. For an integer, like let's say you have a return code, if it's bad, it's generally -1 or something like that. And so in this example, I have a little function that is maybe squared, so it will square the x if it's even, otherwise it will return -1 to simulate like an error case or yeah, an optional value. And so yeah, this of course works, as in I get 16, and if I put 3, I get -1. But of course this is a bit silly, like if you later want to use this value for later computation, you have to know that you have to check for a -1 in case there is an error. Like, yeah, this is not great. It can lead to a lot of mistakes. And so there, with std optional, the great way, the great thing about it is that it forces you to check if there is a value. And so the way you use it is, instead of returning an int, you return a std optional that contains an int. And so this doesn't change, but this will instead return a null opt, which is basically an optional, an empty optional. And so now foo will also be an optional. And if you want to access its value, you have to do .value, like so. And so yeah, and now like since this is 3, and so it returns null, and when you try to get the value of a null option, it will, if you call value, it will throw an error, like a bad access optional. And so yeah, the dot value is basically the way like the compiler forces you to check if there is an optional. And so if you want to actually check if there is a value or not, you can do foo.hasValue, and this will return true if it's not null. And so now you see that nothing happens, and let's say foo is null opt. Up, like so. So yeah, foo is null opt. But if I put 4, I get 16. And so that's basically the main use for it. But yeah, there is a few more things to know about it. First of all, like the dot value is kind of like the, let's say, you get an exception if it has no value, but like throwing an exception and making the check can be a bit like if your thing is like performance critical, it's not great. So what you can do is use the dereference operator, which will do the exact same thing, just that if you do not check, like if you dereference like an optional that is null. So if I put 3 in there, instead of generating an exception, it will just return you garbage data or crash according to your thing. There is also a thing to get the value or a default value. So I can do value or 55, let's say, and so 55 would be here. The null opt would be like replaced by 55. There is if what it contains would be like a struct or something, you could also use the regular like arrow operator to access whatever member of the contain value. Also, the has value is a bit like the more verbose way. So let's go back to this example to make it not verbose at all. Foo implements the operator bool, so it can be converted to a boolean implicitly. And so it will just basically kind of do this here. for you. And so this is another way you can check about it, check if there is a null or there is a value. Yeah, you can also, like, let's say here for, so now I have a value, you can do foo.reset, and reset will just call the destructor of the contain value and set your optional to null, like so. And in C++23, they also added what they call monadic operations, but it's basically very simple. What you can do is do auto, let's say, let's call this one bar, and let's do foo is equal to bar, let's say, transform, because this is probably the most useful one, which takes a lambda, which takes the contain value, so let's say x here, and let's say we want to return minus x, like so. And what this will do is that it will call this function if the optional has a value. Otherwise, if it's null, it will just return null. And so here you can see that if I call it, we can see that foo is still null, so the transform wasn't called. But if I call with tree, which will generate the null, okay, I'm not sure what I did there, but yeah, with a tree, well, foo is still null because bar was null, and so transform had basically no effect. But if I put 4 in there, it will return minus 16 because it first returned this, so an optional with a value inside of it, and then applied the function on it. There is also the other and then function, which is basically the same thing, but here you have to return an optional, like so. Yeah, this exists because you can then have a function that itself may or may not return a value, and you can kind of chain them together. Like if you have a series of operations that are all optional, you can do and then on it, and just chain them. In C++, this is a bit clunky with the lambda and the functions being quite verbose, but in other language like, I don't know, Haskell or Rust, this kind of construct is very neat because, there is a lot of syntax sugar for you to pass your value like through a pipeline, and if at any moment you have a null, it exits the pipeline for you, and you don't. And like all the ifs are kind of invisible to you. So this is kind of neat. So this is the same result. There is the opposite of and else and then, which is or else, which also I think. Oh no, I think this one takes x as an optional or something. Huh. Oh no, okay, so the or else function doesn't take any argument, as far as I understand, yes. So it doesn't take any argument, and so basically if bar is null here, it will just return whatever is the result of this function. So in this case, let's say I want to return 42 if it's null. So here it won't be null, so it should return 16. But if I make it if I make bar null, it will call this function and return the optional here. And so again, this is a way to chain and kind of have like, it's basically value or, so you can have a default value except, well, it comes from a function. That's basically it. And so yeah, that's about all there is to know with optional. Yeah, I hope it helps you prevent a few runtime mistakes and move them at compile time. Let the compiler do the work of warning you when you're doing stuff. And yeah, see you in the next one.